Any other questions? Okay, if no, yeah, thank you very much, Gayatri. And then
Thank you, sir, for this
okay,
wonderful opportunity.
thank you. And then for the next keynote, I give it to Dr. Kapil to lead.
Thank you, Dr. Filbert. Let me introduce, because the session was like very good, and every presentation was presenting like, very new things. This was great experience to listen all these participants. So without taking a lot of time, let me introduce you our next keynote, and maybe the final keynote also, by Professor Sven. Sven Groppe is a professor at University of Lübeck, Germany. He was a member of DAWG W3C working group, which developed SparkWell. He was the project leader of the DFG group, DFG project Luposdate, and 2 research projects on FPGA acceleration of relational and semantic web databases, and is a member of Hardware Accelerator Research Program by Intel. He is currently the project leader of German Research Foundation projects on GPU accelerated databases, indices, and on semantic Internet of Things. Furthermore, he is leading a project about quantum computers accelerated databases optimizations, and he is project partner in project about COVID-19 high quality knowledge graphs, visualization and analysis of pandemic with 2 French partners. His research interest includes Internet of Things, semantic web, query and rule processing and optimization, big data, cloud computing, peer-to-peer networks, data visualization and analysis, and visual query languages. So with this biography, let me give it to the Sven, Professor Sven.
Yeah, hi all. Thank you very much for your nice introduction. Let me first, I hope you understand me. Let me first, yeah,
it's now
share my screen. I hope you can see my screen.
Yes. Yes, we can see.
Okay, I will proceed. So my keynote is about leveraging artificial intelligence. I must move this window away. Let me see, otherwise I don't see anything. Leveraging artificial intelligence and machine learning in pandemics using COVID-19 as a case study. If you think about, COVID-19, then you see all people all around the world have some experience with it, that all have to deal with some unknown issues. Suddenly the pandemic was there and all have to be reorganized. And you also see it right here, that in these conferences, Isaac and Ayek, they are born in COVID-19 pandemic. So maybe, in the millennium time, some said, okay, these are the millennium times. Now maybe they say, okay, these are the pandemic times, and some new efforts have been done, some new things come through, and so on. And we see it in the organization of Isaac Ayek and all the other conferences, why there what dramatic changes has to be done because of such a pandemic. So we just see it. I give it here the example. Isaac, for example, in 2021, it was first planned in person, the first edition. But it come quickly we aware of that it will not be in person. It cannot go in person. So then we have to reorganize it. It's going hybrid. Mary College, New Delhi, India. In 2022, it was first planned hybrid, Georgia Southern University, but then we changed to online. And for Ayek, we already did this with a hybrid mode. And in 2021, the Isaac was one of the first conferences for this hybrid mode. It was, yeah, the experiences was very good right here. And some things changed also before the pandemic. You see that online and hybrid conferences didn't have any good reputation. They said, oh, if it is online, a remote conference, the ranking is very low, no good contributions, and so on. But this changed. There was no real reason for it. They just said, okay, all good conferences are in person, top-ranked conferences are in person. So if it is not in person, then it is a bad conference. That was what the thinking of the people, of the researchers was. But that changed, you know, that changed quite much, because after the pandemic, all inclusive, also the top-ranked conferences have to go online or hybrid, you know. But there was, yeah, some real advantages with it. There is no traveling necessary. Less time is consumed for the people right here to go to conferences. So more people, yeah, are participating, even those not able before. No, so those who cannot travel or have a lot of teaching duties, don't have any budget, something like that, all that people can now come to the conferences and can participate. Or maybe it would be too much stress or something like that. And also often the registration fees are normally lowered for this remote participation, or some conferences even go for that they didn't ask for any fees at all. So researchers with low budget for any reasons could also now participate and submit papers and so on. So very positive effects on some way. Of course, there are also bad effects, like no social contacts anymore, or not so much. We only see us yes during the screen and not during the breaks, and maybe we don't discuss so much, or maybe some questions are risen later, and if we see them later at the event, as a social event or something, we can raise these queries, but not, yeah, but that's, maybe we can also ask via email or have some messenger right here, but yeah, it's more easy if you see them just right there in the social event or something like that. So that maybe becomes a little bit bad, but even that, if you are used to it, you get very much context also to all the people by just being not shy, and also writing emails and so on, writing for contacts. Okay, but on the other hand, there are also more choices, which allows you more picking of sessions and presentations by the participants. So they maybe see, okay, this is interested, but that not, and they only look at this presentation. And for the event, if you are in person there, then you sit down in one session and look at all the presentations. That maybe also some bad effects, but that depends on the person right here, because of course you can learn by all these presentations, and if it is not related to your to your topic, then maybe it is much or you can learn more and more than you just look at watch the presentations of your topics. So, but of course this means that the whole conference committee, the whole organizers are all affected with it. So all organizers don't know, can we go in person, hybrid, online? What should we do? What is the situation in some months, or half year later, 1 year later, something like that? All that makes also a lot of trouble and a lot of replanning. You know, there must be much communication in the advisory committee. We have a very good advisory committee in our conference, so we have a lot of experience and a lot of good opinions, and that contributes to the success of our conference right here. And of course, okay, general shares are heading all the stuff, but it comes more that more and more work, of course, has been done by the track PC shares. I have to thank Valentina, Manas, Asha, especially for their efforts right here. It depends also, they of course makes the publicity, but also we have a publicity share, Rafiq Islam, where we have to look, okay, how to announce it, because maybe sometimes we don't know what we really go for, you know. That's very difficult for the conference organization somehow. And I want to thank all first now here also for their efforts right here. Also the organizing shares for the local organization here, especially ATEF. I want to, and Asai, I want to especially thank them very, very much, because for them it was a very bad situation, because do you have to plan for all their have some in-person event or not? They need to hurry much if it is for in-person conference. If it is only online, then there is nothing at all, and you have to make contracts. Okay, in case of COVID-19, something like that. Regulations, confinements. You cannot. This and this event should be no cost at all. If we cancel it, something like that, that makes a lot of trouble. And I'm very, very thankful for his efforts. But but that's all goes through the workshops and special shares. Green Pratik, they also don't know how to announce it, how to get people involved. Should I say, okay, you have to come to the conference or not? So to some organizers of some workshop tutorials, special sessions, and so on. You don't know it. So what to deal with it? That is a very big problem. Of course, all are aware of COVID-19 and the problematic situation, but they also asked, what is the situation there? And they also say, okay, I don't know if I can come, something like that, so maybe I don't organize, but you must convince them to organize. Okay, publication shares, that's maybe a little bit less right here. There, of course, Sashi, Georgia, and so on, preparing the publication with Springer and so on is maybe as usual, but in the past, you didn't get any proceedings for remote, or it was very difficult to get proceedings for remote conferences. You know, some proceedings said, publishers of proceedings said, okay, we can only go for giving you the proceedings, publishing your proceedings if it is an in-person conference, because of the reputation of the conference, you know, and that makes first also a little bit trouble, but as I said, all the publishers already go for it. And of course, the website, they have to put all the Mohammed, Ahmed, they have to put all the efforts inside to change very often, very quickly the website according to some changes. And that's much more trouble, much more things to consider as before. And of course, I have to also thank the program committee for the very wonderful, wonderful reviews right here. Of course, that's not so much affected by COVID-19, but as you can imagine, it is really, really difficult. But yeah, you can say it's like this, that maybe it was already proven by pandemics, this conference. Okay, and if you if you see right here, the curves of COVID-19, confirmed COVID-19 cases and deaths, you see a lot of waveforms right here. You see, okay, when COVID-19 reaches the continents, you see in the back here the big Omicron wave, which towers up all right here. You can also switch the map and you can see, just to say it again, you see it, the whole world is affected. For some nations, we don't have so much data. There should be much more data right here. Epidemic events are not a new phenomenon. They have a long history. Also, this figure about daily confirmed cases and confirmed cases are not a new visualization. For example, so for the Great Plague in London in 1665 and 1666, this historic chart of mortality shows already this waveform. So there's already a long history, but before the pandemic, no one knows it so exactly. So a lot of people needs to be informed about what it will be like this. And of course, there's some certain insecurity that, that right here, that it will be also the waveform, or maybe it will be another form right here. You don't know if there's really an end of the pandemic right here at some point. When it is, you saw already this figure right here that there are more and more waves, and suddenly the top of the wave is much more as before. So a lot of surprises. When we look at the history of pandemics, then we see that pandemics have always been a companion with humans, even in modern times. We also see that the number of deaths is varying, and COVID-19 still caused a high number of 5 million, maybe a little bit more now already, but it is not the largest number of deaths which has been caused, for example, by the Black Death with about 200 million, the smallpox with 56 million in the modern times, HIV, AIDS with 25 to 35 million. If you look at the numerous epidemic events in the years just before COVID-19, we should be astonished that there was not a pandemic with such extreme effects like COVID-19 before. You know, it should happen already long time before. It's quite unusual that we don't have many more epidemics. I don't want pandemics every year or something, but it's very strange that there are so few pandemic events right here. But yeah, this reminds us to expect also pandemic with a global scale at any time in the future. So epidemic events also occurred on each continent. For epidemic events, it does not matter if the nation it occurs in, if it is an industrial one or not, and how rich its inhabitants are. So it's a global phenomenon, you could say. It's somehow fair at this point, but anyway, you see all people are affected right here. Which countries typically have a high global health security index, such that their health systems seem to be highly prepared for the battle against the pandemics? You see it, but if you look, if you check the cumulative confirmed COVID-19 deaths per 1 million people per country and put this into relation with the global health security index score, we see that the global health security index score does not protect from many deaths caused by the pandemic. Yeah, at least in the early days. Maybe later on, it changed a little bit, but in the early days, for many nations which have a very high income, very high budget, it breaks down the national health security system. So hence any of the health systems are not really prepared to handle such an extreme situation like the pandemic. So in order to avoid the total breakdown, additional actions like, for example, COVID-19 confinements have been and are still necessary, like wearing masks, reducing the social contacts, and even lockdowns of the economy. We get to know, okay, for at least COVID-19, this is more for the case for the winter, autumn, winter, something like that, not spring, summer, but maybe the next autumn, winter, it will be the same again. We recognize the speed of the virus when looking at the daily number of confirmed cases, as before. When we look at the timeline of the COVID-19 pandemic, then we recognize, on the other hand, that there was also great speed in research for contributing with and utilizing all the new technologies against the pandemic. The virus still won, you could say like this, but we cannot imagine the enormous dramatic situations which would have been taking place without the fight of researchers against this pandemic. The start of the pandemic could be dated to the 7th January 2020, where the virus is recognized as coronavirus within weeks of the first identified cases of pneumonia of unknown cause, thanks to supercomputers. Only 5 days later, on the 12th January, supercomputers and big data allowed researchers to analyze the genetic sequence of COVID-19 patients, later also SARS-CoV-2 mutations at population scale. Based on the SARS-CoV-2 genetic sequence, the development of testing kits was only a matter of weeks. So in the end of January, person-to-person transmission was already confirmed, which is the basis for and of the need for contact tracing technologies. And already on 19th February, so the speed of research was very high. We should be very proud of it. The spike protein was mapped, which is the basis for the different vaccines against COVID-19. There's been hence the start date for developing COVID-19 vaccines. It is also the start date of the real-world applications of mRNA vaccines and of the success of mRNA vaccines, which very successfully defeat COVID-19 and made vaccination developers really rich. You can see it at the stock exchange. The mRNA vaccine type fast tracks research and development by requiring significantly less data to be sent to human cells compared to traditional vaccines. But of course, we should be, we should not say, okay, this COVID-19, we dealt very well, something like that. In future pandemics, it could be all different. So in the early days of October, airborne transmission turned possible. Amidst waves of outbreaks, governments used big data and artificial intelligence technologies have been used to predict transmission in their communities and across their borders. The data was digitally collected in real time from sources like mobile phones, mobile payment applications, and social media platforms. In the early days, the first vaccine, spreading hope for a fast end of the COVID-19 pandemic, has been approved in UK, and others entered stage 3 clinical trial evaluation, such that other vaccines have been approved in the following months too, leading to one of the largest vaccinations in history. There have been problems to produce so many vaccination doses in very fast time to vaccinate the whole world's population, which is still ongoing in these days. There have been dramatic scenes where people wanted to be vaccinated before all the other, struggling much, maybe sometimes even use forces and so on, which should not, of course, not be like this. Most countries prioritize its population according to age, the health status, and contact to COVID-19 patients in order to regulate the order of vaccinations. Since December 2020, common variants of the COVID-19 virus produced global concern. it seemed to be that each mutation was even more infectious compared to previous ones. And vaccinations does help less, but still bewares of heavy developments of the illness. Researchers used hence continuously supercomputers determine the sequence of variant genomes for global mutation, surveillance, and vaccine FESC assessment. And somehow this is the same now, still ongoing. So computer science and computer applications, that's more the topic of my talk, can now help in the fight against the pandemic in many different ways. So machine learning and computer simulations predict incidence rates, which may also consider contexts like COVID-19 confinement. A whole bunch of artificial intelligence and machine learning approaches have been developed and evaluated for their accuracy in prediction. I will enumerate the AI and ML approaches used in the fight against COVID-19 on some later slides. So in the detection of chains of infection, we need to manage physical context. For example, at events in restaurants where support of software can automate a lot of routine work. For example, a lot of systems provide support of just scanning QR codes with smartphones. We all know this, to check into a certain venue with the purpose of controlling infection chains. And they have automatic means developed to warn single persons for probable infection and maybe even the public of certain regions with an increased danger of infections. Besides routine work like patient registration and status updates in hospitals, new special technologies needed to be developed to update e.g. databases of confirmed COVID-19 cases at the daily level. Also, other methods have been considered for the detection and diagnosis of COVID-19 patients based on computer tomography scans, where again a lot of AI and ML approaches play a major role. Here we see the machine learning and artificial intelligence approaches as named and applied in the scientific literature for different tasks in the fight against the COVID-19 pandemic. It is based on a systematic survey by Dogan et al. In 2021, where finally the 264 papers have been considered. We see that about 50 different ML and AI approaches have been applied and evaluated in the COVID-19 context. Not surprisingly, widely used ML and AI approaches in other contexts like convolutional neural networks, rainbow forest, ResNet, support vector machines, deep learning, sampling, importance, resampling, regression models, and long short-term memory belong also to the most widely used ones in the COVID-19 context. That's also not surprisingly right here. So in other contexts that helps, but one thing all have to now think about is, okay, in what way the COVID-19 is special and requires new development of ML and AI approaches. What is special about this data and what we can do to adapt to it and deliver its new ML and AI approaches. In the moment, it looks a little bit like, okay, we can fine tune a little bit, but a whole breakthrough based on these findings with COVID-19 data is not being done, but we can fine tune it to COVID-19. So in this chart, we see for which application domains the most widely AI and ML approaches are used. So prediction here refers to estimating incidence rates and other rates like hospitality. Diagnosis of COVID-19 using AI and ML methods refers to identifying how the disease is spread in an individual by evaluating symptoms and analyzing data, while the classification of COVID-19 using AI and ML methods refers to classifying the data into binary or multi-class. Hence, diagnosis is something more than a pure detection of COVID-19, which can be often done by classification, but should deliver some more information, which might help the medical personnel to apply a medical treatment. Again, diagnosis can be often done using classification. Assume we have some patient's data like symptoms. With the help of classification, we can identify the type or class of disease. Other applications include early warnings and alerts. So according to Dogan et al. In 2021, the review results indicate that most of the models, almost 50% of studies, used ResNet for classification. Recent advancements in deep learning led to the potential usage of various convolutional neural networks architectures. Next to ResNet, some authors attempted the CNN model for classification. That's about 45% of the studies. Few authors also tried to use traditional ML algorithms like support vector machines and rainbow formulas for classification of COVID-19 data. And prediction is then the second popular objective in AI and ML approaches. Regression analysis is a widely accepted model for prediction purposes with about 100% of the studies. Deep learning models are another popular prediction approach, which was adopted by about 70% of the studies. One of the most used mathematical models for the COVID-19 pandemic is sampling importance resampling frameworks. More than 60% of the studies used the SEER framework, is the abbreviation for it, for prediction. Diagnosis is the third popular AI and ML. LI and ML usage purpose. Rainbow formulas and support vector machines techniques were applied for diagnosis of COVID-19 with nearly 25 to 30% rates, respectively. As deep learning-based models, convolutional neural networks and ResNet were used to classify, predict, and diagnosis purposes. The results produced by this comprehensive review prove that AI methods are a promising mechanism to use for the current scenario of the COVID-19 pandemic. So, one of the most prominent examples for technologies most widely used and especially developed against the COVID-19 crisis are mobile apps for contact tracing. Those apps have been developed because COVID-19 patients often get to know that they are infectious, not immediately, but sometime later, until they have been tested or got symptoms. Infected people can already infect many other people. Hence, these contact tracking apps are used to find out all people which got in contact to an infectious COVID-19 patient, can help saving life. The requirement is for most techniques that the addressed people carries their smartphone with them, having the contact tracking installed. Contact tracking app installed. An exception is the mobile operator contact tracing, which is non-intrusive and can be put in place without any other intervention, assuming a legal framework is in place, which allows this, of course. During mobile operator contact tracing, the location of a mobile phone is determined by the mobile operator. Hence, an app is not necessary, but only those carrying a smartphone with them are alerted, and not the other. It has an accuracy of plus minus 140 meters, so in urban areas, but up to kilometers in rural areas, such that it does not work well in rural areas, of course. So for location-based contact tracing, the location is determined by on-device capabilities of smartphones. For outdoors, GPS with an accuracy of plus minus 2 meters for precise location is utilized. For indoors, device site cell tower multilateration and crowdsourced Wi-Fi localization with an accuracy of plus minus 10 meters with newer access points with an accuracy of plus minus 1 to 2 meters is used. However, again, this requires the installation of an application on the participating smartphones, right here. An installed mobile app is also required for proximity-based contact tracing. So for this approach, Bluetooth and Wi-Fi are used to infer the relative proximity of smartphones by transmitting a small range signal that others can hear and record. So that is an accuracy of up to 50 meters outdoors and 25 meters indoors for Bluetooth. So according to the General Data Protection Regulation of the European Union, and other states, of course, have somehow similar data protection regulations. So in general, basic data protection principles such as data minimization, sharing the minimal amount necessary for the service purpose, purpose or storage limitation, which limits the use of data to the service's clearly defined purpose and limit its storage in time to the period the service is provided. That should be all guaranteed by the contact tracing application. And all the people have to, or some people have to check it, but it helps if it is open source and this stuff. This means that the system should not learn more information about individuals than what it needs to fulfill the functional requirements of contact tracing right here. So if you, I overjumped that slide right here. So even if, when following the basic data protection principles, and even if it is checked with open source and something like that, there are still, different kinds of privacy risk for contract tracking. There I list some few here, and which must be taken care of by a careful design of the tracing application. So the health status privacy is about leaking the identities of users infected by COVID-19 or who have been in contact with them. This information should remain accessible only to the infected users in the health authority. The location privacy is about leaking as users' mobility trace. Therefore, geolocation-based, the location is required to infer proximity, and for Bluetooth-based apps, the co-location information can be leaked with the danger of local Bluetooth sniffing station. And the social graph privacy is about leaking the user's social graph through proximity data between users for Bluetooth-based systems and based on location data for location-based. There's no need of a global social graph to perform contact tracing, but only the contacts between infected users and other users, which is some kind of proximity and local graph. With knowing the social graphs of the significant number of users, one can de-anonymize these users by covering with, e.g., social graph in social networks. Okay, I will jump over this slide right here, and of course, we can then also evaluate the contact tracking solutions, how well them there, give some marks right here, and give some recommendation which one to use right here. But I will also jump over it. I can give the reference to the slides. There's also a reference to the paper which deals with it more in detail. You can look at it. But there are also other items. So many nations have contact tracking teams which manually tracks the contacts by asking infected persons about their contacts and where they have been and so on. It did not replace this manual contact tracking. Some nations also use other means for this manual tracking. And one is here, for example, South Korea, which already before has an aggressive high-tech contact tracing team that harvests credit card records, cell phone location data, and CCTV footage, among other personal information. South Korea now checks automatic means for the contact tracking besides contact tracking apps. So a pilot project about AI-powered facial recognition to track COVID-19 cases became operational in this January, which rolled out in the Wuhan area with a population with more than 800,000 people. So in the Wuhan system, AI algorithms and facial recognition technology are used to analyze footage gathered by more than 10,820 CCTV cameras and track an infected person's movements. Anyone they had close contact with and whether they were wearing a mask or not. South Korea already does this before by manual work, which currently takes half an hour to 1 hour to track one person. So they look at all the cameras and track infected people once. With a new system, the new system can now simultaneously track up to 10 people in 5 to 10 minutes, which is another dimension in tracking and help the overburdened manual tracking. You know, that becomes another dimension. Right? Of course, there's some critique, and the opposition in South Korea compares the new system with Big Brother. Right? Of course, that's also true. It depends on also on the regulations in some country and maybe also on the population if they go fighting against such systems, something like that. On the other hand, there are some positive effects, of course, that they get to know much more infected people. But you could now blame South Korea for it, but there are a lot of other countries, China, Russia, India, Poland, Japan, and several US states have rolled out or at least experimented with facial recognition system for tracking COVID-19 patients too. And of course, again, you can say, okay, that is something, is a no-go, or it should be like this. That is a, I don't want to have this discussion right here now. I just show the possibilities because this discussion belongs to the society of each nation if they want to go for it or not. There are also other impacts on daily life of the COVID-19 pandemic all around the world. COVID-19 confinements have been past parliaments. One very crucial one was the partial and full school closures right here. We know this. In this figure, we see the school closures as well as schools offering online learning as of February 2021. Now it is more relaxed. There it was in the peak of the pandemic. We see that different nations have different strategies for the COVID-19 confinements. And we could now also analyze the effects of this and other COVID-19 confinements on parameters like incident and hospitalization rates. While for pupils at school, this had enormous effects. We recognize that the COVID-19 pandemic was a huge trigger for research. If you go for Google Scholar search, then several 100,000 publications have COVID-19 in their title and several millions publications contain the word COVID-19. We recognize that the peak for the number of publications was already in 2020, but it could also be that Google Scholar still does not index all relevant publications. So we have to wait still a little bit if there's really that this conclusion, is somehow preliminary and must be checked then later on again. We also see that the estimation of number of publications provided by Google Scholar is not really exact because the number of publications at any time are less than the sum of the publication in 2019 to 2022. So researchers always need some data to play around with it. Yeah, you see it here. We need data for our artificial intelligence, machine learning tasks, and so on. There are numerous data sources freely available thanks to all the researchers worldwide on the internet. You see here only 3 examples of these data sets. These 3 examples have been used in many publications to find out new clues about COVID-19. Sometimes these data sets are only used to benchmark new approaches. Some data sets are published on Kaggle, where you can easily play around with these data sets with Jupyter notebooks running Python and other programming languages and frameworks for data science stuff. For example, the COVID-19 Open Research Dataset Challenge contains more than 500,000 scholarly articles, including over 200,000 with full text about COVID-19, SARS-CoV-2, and related coronavirus. Along with Kaggle datasets, you can define tasks, what data scientists can do and find out with the dataset. The COVID-19 Open Research Dataset Challenge comes along with 17 tasks like what is known about transmission incubation and environmental stability. For solving these tasks, there have been already more than 1,600 notebooks on Kaggle. The novel coronavirus 2019 datasets covers daily level information on the number of affected cases, deaths, and recovery from 2019 novel coronavirus. 7 tasks like, can we correlate weather conditions and coronavirus speed through data, have been proposed for this data set, leading to more than 1,500 notebooks on Kaggle. So very many people working on that right here. The Open COVID-19 Data Working Group is about cases of the coronavirus with over 71 million confirmed cases worldwide. As already pointed out, there are many more data sources about COVID-19. When searching for COVID-19 data sets on Kaggle, then there are more than 2,500 results. Probably there are millions in the internet. But that is just a prediction. One of the most widely known one is the COVID-19 data repository by Johns Hopkins University. So in Germany, maybe in some other countries, they use, or journalists use this data, and all the charts in news and so on are based on it. For national statistics, we have another institute, Robert Koch Institute in Germany, but I think that is also included in the Johns Hopkins University data repository for COVID-19. So this data set contains daily updates on confirmed COVID-19 cases and deaths, active and recovered patients, incident rates, number of people hospitalized and hospitalization rate per nation. The data set is often referred to by, as I said, journalists right here. I think also in US, I don't know, in India, maybe you can give feedback about it, or if they have other sources right there. They look for it that that the data is collected from very reliable data sources like the World Health Organization, European Center for Disease Prevention and Control, SCDC, Worldometers, COVID-19 tracking project, and so on. And they also have a visualization board for it. So the next thing which comes in play are knowledge graphs. So knowledge graphs mainly describe real-world entities and their interrelations, define possible classes and relations of entities in a schema, allow for potentially interrelating arbitrary entities which each other and cover various topical domains. In our case, we are, of course, interested in COVID-19 knowledge graphs, which we can use to formalize background knowledge about COVID-19 and all what is related to COVID-19. There are already many COVID-19 knowledge graphs really available. For example, the COVID-19 surveillance ontology has applications, surveillance and primary care. There are knowledge graphs in the infectious disease domain in general and specialized to COVID-19, complementary to data sets about COVID-19 data sets. Knowledge graphs about literature search do their job in bringing structure and classification to these data sets right here so that you can find literature much better. Other knowledge graphs are about drug repurposing, risk factor discovery, case statistics, and multi-purpose ones having several applications like phenotype, recurrence, drugs, COVID-19 response, and SARS-CoV-2 virus host interaction mechanisms right here. So how do these knowledge graphs look like? The Kido and Kodo knowledge graphs are given here as examples, have between 10 and several hundred classes, properties, individual and logical axioms. Maybe there's a newer version which has much more. So Kodo contains over 71 patients, leading to approximately 5 million triples. That is the information I have. I guess in the now already the statistics should be already updated right here. So in knowledge engineering, the knowledge engineer first collects so-called competency questions, which are used to know what questions should be answered by the knowledge graph and limit the domain of the knowledge graph right here. And yeah, competency questions can be used after creating the knowledge graph to test the knowledge graph. If the knowledge graph covers the knowledge graph of the applications it is developed for. In short, with the competency questions, one can often see what you can do with the knowledge graph and what you cannot do with the knowledge graph. For example, the CODO competency questions include find all people diagnosed with COVID who are in family relations, give all patients who have contacted the virus from another, give all patients who have passed the virus to 2 or more possible patients, find the city patients, find the cities patients have been traveled to, gave all patients where we know the reasons they caught the virus, find all clusters and the patients in them, and so on and so on. So there are many questions which you can already answer with knowledge graphs. It's very good. But yeah, which knowledge graph to choose? It's another question. You know, of course, you could look a little bit at the domain, but yeah, which ontology you should go for is really another question, because there are already many competing ontologies and also knowledge graphs right here for it, and you don't know which will survive. You know, later on maybe they are not maintained anymore, and your application becomes an outdated because you don't use the right ontology or an outdated ontology and outdated knowledge graph. So you just can start a search for COVID-19 in the name of classes on BioPortal. BioPortal, maybe you know it, is a community-driven effort to maintain ontologies. Just we can try out it overall. Here you have the URL for it, and here you see some part of the result. So you see the ontologies having a class with COVID-19 in the name, but also those ontologies reusing these classes. And what you can also do about in BioPortal, there are also other portals for it. I just give it here as example. Is you can also check further information about an ontology in BioPortal. You just have to navigate to the ontology page. So each ontology has some page, and there you have a description, of the ontology, and you have a matrix right here. For example, the number of classes, properties, and so on. Right here, there are different versions of the ontologies archived and different views in different languages. Right here, and as well, the projects using this ontology is listed. Especially the last may not be complete because BioPortal is a community-driven initiative. You just have to remember it. Okay, overall, the search result, if you look for COVID-19 in the name of a class, includes 30 ontologies. Although only 19 of them integrate classes with a label, especially containing COVID-19, and 7 of them are exactly matching COVID-19. And there are also here the reusing, or those ontologies reusing these classes of some basic ontologies inside. This figure also provides statistics over the number of individual classes, properties, and usages in projects as added to BioPortal. It also shows the used ontology language and natural language variants. This picture and some more information are also given in our keynote paper. So we have written some keynote paper in the length of full papers right here, and you can check them once the proceedings have been published for further information about this. So just to give an impression right here. All ontologies support English labels, but 2 have French versions and 1 a German version of the ontology. So other versions, language versions, are not usual. That means the number of individuals declared in these ontologies is often 0. That is about 50% of 50% of the ontology is the case, but can be up to about 50,000. That's for the E2 ontology. The minimum number of classes is 2. That is Vodana COVID and some MW content, and the maximum is 350,000, something like that in Normandy. If you have less than 1,000 classes, that is 27%, and between 1,000 and 10,000 classes, there are 20% of the ontology. So most ontologies have between 10,000 and 100,000 classes, that is 37%, and some few are larger than 100,000 classes, that is about 17%. The number of properties is much less than the number of classes, ranging from 0 to 2,000, something like 2,000 for E2. 20% of the ontologies have less than 10 properties, 40% have between 10 and 100 properties, 37 have between 100 and 1,000 properties, and only 4%, that is one ontology, have more than 1,000 properties. Just to have some statistics that all these numbers vary quite much right here. So the important question is now which ontology to choose for your COVID-19 application. So not all COVID-19 ontologies will survive. I already pointed out. So many ontology will not be maintained anymore in the future because, for example, funded projects and no money is there anymore for maintenance. Some ontology are not widely used, which may be also not good for future maintenance. Hence, you might want to choose the COVID-19 ontology with high impact. You must have some way to measure high impact, such that there's a high probability for being maintained in the future, and your application has a higher interoperability with other applications because they maybe also use the same ontology. So hence, we have to check how to measure this impact of COVID-19 ontologies. So the number of reusings can be seen as a metric for ontology impact because a high number of reusings is a sign for the popularity of the reused ontology and its classes. That ontology users stumble over the reused ontology again when applying the reusing ontology and makes more reusings more likely. And yeah, you can see, okay, this would be the resulting ranking right here. Yeah, you can see, okay, we have do it with 6 reuses, Mondo with 2 reuses, and 1 reuse. We have surveillance ontology, medical hash, subject headings mesh, and National Cancer Institute thesaurus. But that makes us not much confident because only some few ontologies have this reusing right here. But that should be maybe taken into account. The number of usages in projects is an obvious measure for the ontology impact too. However, this given number of usages in projects in bioportal is incomplete. I already discussed it. More sign for good maintenance of the ontology itself, and motivated ontology developers and project members pointing out these usages of the ontology. But nevertheless, even considering these issues, the number of usages in projects remains as a good metric for the ontology. Not surprisingly, established ontology with a more general domain than COVID-19 are used in many projects and hence are better ranked according to the metric of project usage. Up to 5 ontologies specialized for the COVID-19 domain have at most 1 usage in projects. So here you see the overall result for this. So we define the usage of a given ontology in projects as the direct usage, and the usage of an ontology reusing the given ontology as indirect usage of the given ontology. In indirect uses, the given ontology itself is also applied. And hence, we should take this number for the overall ontology impact in consideration. As there are only few ontologies, we using a class containing COVID-19 in the label, also considering the indirect usages obtained from the result of our research in bioportal changes the rankings only slightly right here. Yeah, they are now here in red, where we have slightly changes. So in future work, we might also consider data sets other than bioportal for usage of ontology and projects and otherwise metrics based on other properties like searches in ontology search engines, number of instances of ontology classes in knowledge graphs, number of applications using these ontologies, and number of accesses to instances of ontologies in applications, and so on and so on. So, but of course, it's a question, bioportal is there. You can easily get the information from bioportal, as I pointed out right here. Maybe it's more difficult to get this data. So there we have this data, but I think that would be one thing we should, we should go for to measure the impact of ontology, knowledge graphs, and so on, to get more and get reliable rankings about what is the impact of these ontologies. You know, and as I already pointed out, of course, not only impact of ontologies, also impact of knowledge graphs, data sets, and so on, of COVID-19 or of general domains, other domains, we should also look at. Mr. Morko also asked, as I said, we have a paper about it as full paper in the proceedings of this, of this conference right here. Please check the further things right there. So we have some other things. I have also some advertisement for it. So you have, you can also check an edited book by Lee Grünwald, Sarika, Jane, and me. So if you are interested in any of these topics, you can read the edited book. It covers most and some other topics in the addressed areas of the keynotes. Here you see the table of contents just for your reference. So we also come now back to COVID-19 knowledge graphs. I think I still have only some few minutes. Also some advertisements. There will be a French-German project starting soon with the partners of the University of Paris, dealing with the data quality topics, the University of Toulouse, dealing with natural language processing, and our university and institute being responsible for semantic technologies, data visualization and analysis. Our project deals with high quality knowledge graphs where you can track the source for claims about COVID-19 and see refinements and untrue statements which have been believed until they have been refuted. Right here, that is the main purpose. Also effects of COVID-19 confinements and other influences should be made visible. So we will be now just starting with our project. I hope, or I'm confident from the last 2 years, we get already enough data to go on with it. But we will see also that, we don't want the pandemic going on right here. Of course, for our project, it would be quite fine because then we will have, hot topic to publish about, but we are already confident for the 2 years is enough to also run this project right here to have research for the coming 3 years right here. So from our side, the pandemic can stop right here. I think I already talked about 1 hour, so I will quickly go over the rest of the slides. So in our architecture, we will have a loop right here. I'm checking the module, looking for new facts and facts according in different nations, something like that. We have also data analysis and visualization part right here to increase the quality of our results right here. And one big thing is increasing the quality, and the other thing is enhancing, still collecting more and more information, integrating it. We will have a time machine where we can go to different state of the pandemic right here, visualize it, something like that. Please have an open eye on our publications in the future right here, and any collaboration, of course, in this respect, and also in other things are very welcome. So what I've been talking about is, there is about the whole COVID-19 pandemic. In the beginning, maybe I showed you also the difficulties in organization, in events, with the example of ISAC and IAC conferences right here. We go on with some statistic about incidence rates, global health security index, showing that the number of that the bad effects of the pandemic doesn't make halt, doesn't stop before which countries, something like that. That the whole health systems break down right here, but there are also very much a very timely reaction from researchers on all this pandemic coming over, all the things right here, but we should not expect that for future pandemics that it will work relatively well. Right here, of course, there are dramatic effects, but it could be still managed right here, but we should not expect this for future pandemics, because COVID-19 still, maybe you could say, is a big pandemic, but maybe still there has been already bigger pandemics in the past. So we must be aware of it, and we can already test our AI and ML methods for COVID-19, for the COVID-19 pandemic, but that will be also, and maybe we can adapt them for future pandemics, but we will see. There will be something different, and we must be aware of it that there will be something different right here in future pandemics. And there we have to look also for it. One big part was then contact tracking applications, but also knowledge graphs right here and ontologies of the COVID-19. I make a dive into some of them, but also then showed how to measure the impact of ontologies, knowledge graphs. In this respect, there's some way, because we all must know, okay, which ontology, which knowledge graph we should, which data sets we should use, which are maintained in the future, which is used by many applications for higher interoperability, and so on and so on. And I made a little bit advertisement right here about an edited book about our project. Any collaboration is welcome. We have also one PhD student right here for quantum computing acceleration for database optimization. If there's someone interested, please contact me. In the moment, the job offer is there. The submission deadline is not over. With this, I want to conclude my talk, and I'm open for any questions right here. So I see that Maria Esther is raising the hand.
So can I ask questions?
Yeah, yes, of course.
Okay, so very good work, congrats. So I would like to ask you if you are actually using Shackle to represent constraints and how the process of creating this knowledge graph is defined, if you are using mapping rules and you have this declarative definition of a knowledge graph that allows for keeping track of the whole process of knowledge graph integration.
Okay, the project just starts, so we don't have a running system until now. But Shackle, that is one thing, but Shackle constraints are, of course, maybe the other don't know. So Shackle, you can define the structure of RDF, something like that, and can put there some constraints inside, such that it really can be checked if something is not valid according to a schema. It's not like this, like constraints in ontology, something like that. The structure is really checked. And with Shackle, you can check data sets if there is not something wrong inside, something like that. That is very interesting for us. Right here also, that you can check a whole data set if there are some data inside, something like that. You can check quality also with some Shackle constraints. There you maybe also think about it. But I think that is not the overall goal for our approach. We are more interested in looking, okay, users going for the app and looking, okay, what they are searching for, where some information is missing. That is one thing. And for this, we have here natural language processing part, such that based on this information, we will get some more information from it. You know, will get some more information integrated in the knowledge graph. And also the other things that we go for the knowledge graph and check contradictions inside. Right here, and some vague formulations is maybe also a problem. If you have natural language processing, then you maybe first okay, the attack rate is higher than, and later on how much the attack rate will be higher. And you can check then contradictions even in one source. Maybe there are different numbers or something like that. And of course, you can formulate some Shackle constraints for each of this and then look for the constraints, but we will also, I guess, for other options for it. Does it answer your question?
That's answer my question, but also it will be interesting to see because many of these constraints could be represented in Shackle as well. And you could also, you will be able to quantify how many of the instances are satisfying or not the whole process.
Thank you, of course, for the remark. We will consider this in our project right here, and there's also checks and so on. We will. You could also do a lot with Sparkle, and Shackle can be also Sparkle constraints put inside. So there's a whole bunch of ways right here. There's a real chunk of ways to put it. Yeah.
Okay, many thanks. I also included a link to the whole process of knowledge graph creation, where we are able to specify rules and also execute the rules as the whole evaluation of the process. Okay. Okay. Thank you.
Yeah. Thank you too. Maybe we will contact you.
Thank you.
Saket, do you have any other? You said something. I don't know if you said some question. If you asked some question, are there any other questions?
I do not have a question, but I am really excited to listen to this keynote because I could see an extensive work done to prepare this.
Yeah,
We really appreciate.
Thank you very much. I will post the slides right here into the chat. It's publicly available. All can see it, and I wanted to provide a quite big overview about the topic. And if you like it, then it's very good right here. And I hope it can be never complete, of course, because there are so many efforts, and I can dive only in some parts into it. Right here, that's also clear. But I hope I could give somehow an overview and also some advices what to look for, what to choose, something like that.
Yeah.
That's the thing.
Thanks for that.